Greetings, everybody, and welcome back to another Dirty Beaker series. We are happy to be back with you, and we're happy that you've joined us once again. We hope everybody is feeling fine and remaining safe. And we feel that safety is the operative word in this case because we'd like to have a conversation about the two vaccines that are being offered to the general population that we've seen in corporate media that may not be safe enough to inoculate into human populations based on science that we have reviewed. And when I talk about the science that we reviewed, it leads to the opening title of our conversation today, and that is RAPS, a message for the messengers. And what it means is that, yes, we're going to rap to you today, but we're also going to refer to the acronym RAPS, and that stands for Regulatory Affairs Professional Society. And we encourage everybody to go to this website because it allows you to get an intelligent and informed understanding of all the vaccines that are going to be developed in the upcoming months and years. And so you can go there and get an informed decision. We certainly have, and that's why we're here today to try and talk to you about some of what we've learned about two messenger RNA vaccines that we find problematic at this point as far as safety is concerned, and we don't feel that they should be offered to the general population. Again, a message for the messenger. In that title, it's three-pronged. It's three-pronged in the sense that we're talking about the messenger, meaning the corporate media messenger. We're also talking about the corporations who are sending a message out. And then we're also talking about messenger RNA. And messenger RNA brings it back home to the science and what this is all about. And as we look at messenger RNA, we first have to look at the central dogma of genetics within itself. And when you look at the central dogma of genetics, we say that you have DNA, you have RNA, and you have protein. And I've written back here, DNA, RNA, and protein. And what we mean by DNA for the novice in science, because I have a variety of people that look at the Dirty Beaker series, molecular instructions for what makes us us. It creates the design of the proteins that makes our eyes, our kidney cells, our liver cells, our heart cells, our laughing cells. There are no laughing cells, but of course, what makes you laugh, the muscles that allows you to laugh. But in that case, we need to understand that messenger RNA is important in this sense because RNA is outside of the nucleus. So in a cell, when you're having this molecular understanding of who you are and what's going to make you, there's a portion of the cell called the nucleus that encapsulates the DNA. And the DNA has to have its information transcribed to messenger RNA so that it can go outside of the nucleus into the rest of the cell, make the proteins that are able to be displayed on membrane, as well as being excreted to the rest of the body or being shown to the rest of the body through what we call major histocompatibility molecules. They have major histocompatibility molecules number 1 and major histocompatibility molecules number 2. And we say this to say that when you manufacture messenger RNA, as these two companies have, you instruct your cells to make proteins that have been designed, and that's fine. But in the process of that, designing a protein for your body that is foreign to your body creates additional foreign particles that your body will mount a defense against, and it creates an unhealthy environment for the body. The unhealthy environment creates cancerous mutations to DNA structures. Now, when we look at messenger RNA, it's outside of the nucleus, so it's not completely likely that the messenger RNA can change the DNA within the nucleus and create mutations that would cause cancer, but it is a slight possibility for that. But also, when you input messenger RNA into the cell that is foreign to your body, the messenger RNA, sometimes the ribosomes that are reading the messenger RNA can have misreads. And those misreads can lead to proteins that are not necessarily proteins that you want. And that can create, again, more proteins that could be detrimental to your health. They could mount an immune response, autoimmune response. They could also mount tissue destruction, meaning connective tissue damage, meaning fibroids, meaning that the lipid bilayers of your cells could maintain those proteins and create problems down the line. So the information that these companies, the messengers that are providing for the people, are inadequate because there's not enough long-term safety data on these trials. Now, if you go on the RAPS website, you can look at the Pfizer and Moderna trials, and you can see what these trials actually did. And so I'll go to the Pfizer trial first. The Pfizer trial, based on RAPS and based on clinicaltrials.gov, and you can look this up on the internet, clinicaltrials.gov, and then you will be able to find the Pfizer vaccine trial. And you will find that the vaccine trial only looked at 44,000 people throughout the world, and it was only based on 94 of those people reporting symptoms of COVID-19. So it didn't even look at patients that may have been symptomatic for COVID virus, but it based its information on 94 patients. That's problematic. And additionally, as to why that's problematic is that the infectious rate of COVID-19 is 1%. And if you look at 1% of 44,000 people, you would come up with 440 people. And so if you were going to base an interim analysis based on the data, you would want to have at least 440 people to make some sort of determination as to equate to the actual infectious rate of the general population. But they only looked at 94 patients that were symptomatic. Additionally, what they looked at when those patients were symptomatic, they wanted to confirm whether the patients had COVID or not, and they utilized what we call nucleic acid amplification test, which is a PCR test. You hear it in the media talked about. It's called the PCR test. And when you look at nucleic acid amplification test, you can see based on CDC information itself that nucleic acid amplification tests are only 75 to 90% sensitive, meaning that if a person takes that test and it comes up negative, that 25% of the people that have taken that test will not be negative. They're actually positive. And so it's very important to understand sensitivity and epidemiology if you're going to make intelligent decisions about providing this drug to the general population, and for the general population to understand what this drug, or in this case, this vaccine, could possibly do to their body. Other concern that we have is that the vaccine only deals with the population after 28 days. So it's only 28 days of data. And we know that COVID has an incubation period of maybe 14 days. And if you look at the data based on this population, based on 44,000 people, based on the fact that they've had the vaccine only for 28 days, and that's where the data is coming from, it's far insufficient for long-term safety data as to the types of things that the synthetic vaccine could cause. And we find that problematic. One thing that I do want to say also is go into some of what happens in the design and the development of the compound itself. The compound itself has what we call, and I mentioned before, nanoparticles are small lipids, and lipids are fats. And the body has a defense system. If you just simply injected messenger RNA and expected it to get into the cells and connect with ribosomes, it wouldn't happen because your body's defense systems would stop it. These vaccines are coated with these lipid nanoparticles, which are synthetic lipids, that coat it so that it gets through the body. And the lipid nanoparticles could not only get through the body, it merges with a cell. And once it merges with the cell, almost as if it sort of melts into the cell, as what we call an endosome. It connects its fatty substance with the fatty substance of the cell, which we call a phospholipid layer, which is a fatty substance with phosphates on it. It is able to enter the cell, and then once it enters the cell, it can open up and allow for the messenger RNA to find ribosomes and then print itself out. So as you can see, if that enters the cell in that manner, a lot of those lipid nanoparticles will wind up in the plasma membrane, in that lipid bilayer, and then the protein itself, or excuse me, then the nucleic acid itself from the messenger RNA will implant into the ribosomes and be read out. But again, misreads could create unidentified proteins that could create lots of problems for your body. So I hope that that aspect is clear. Now, the reason that they do that, the reason that they have manufactured a spike protein is not a bad idea. The reason that they have done that is because the COVID virus has some spike proteins on it, on the code. And those spike proteins connect with the angiotensin converting enzyme 2 receptor on pneumocyte 2 cells, which are in the lungs. If you look in the back here, I have a picture of the lungs. So in the lungs, you have pneumocyte type 2 cells, you have pneumocyte type 1 cells. Pneumocyte type 2 cells are the cells that COVID likes to combine with that angiotensin converted enzyme 2 receptor. And the only way that it does that is through what we call an S protein spike. And that S protein spike is manufactured. As we said, DNA makes the protein that makes us us. The DNA of the virus makes this S spike protein in order to be able to enter the cell so that it can take over the cell and allow for COVID to expound in the cell, grow or replicate itself in the cell, and eventually get out of that cell and invade other cells. So in order for scientists to stop that, we think that it was a good thinking to try and replicate that spike protein through looking at the messenger RNA that makes that spike protein and trying to replicate it. And we can do that. We can take nucleotides that, almost like a cookbook, we can take nucleotides that match what the spike protein is, and we can manufacture those nucleotides, and we can put that same mix of nucleotides and that same arrangement together. We do that in a manner that will allow for that messenger RNA not to fall apart once it gets inside and not to read in some sort of foreign way at a 5' untranslatable region. And then we also provide a 3' untranslatable region at the end, and what we call a poly A tail. That's a replication of adenine, 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 adenine. And so that creates stability for the messenger RNA. So the companies have done that, and it makes it more specific. But we still find that the safety data is not long enough in order for us to tell whether that is creating other sorts of proteins that are unwanted in the body. So with that said, and I hope that I haven't completely confused some of our listeners, and if I have, please contact me and let me know. I'll explain a lot more of this as we go along. But the reason that we come here today in the take-home message would be that recently in the news, they're reporting that the Biden COVID task force has a working group, and that working group may tie vaccinations into whether we get our public assistance programs. And if we can tie, and if the government is tying vaccinations to whether we receive government assistance if we need it, then that places us at risk, and it sort of forces us to take on a vaccine that's really not vetted through sound safety science in order to even be given to a general population. And we find that to be very problematic. So that's the take-home message. We are not anti-vax at the Dirty Beaker, but we find this messenger RNA, a novel messenger RNA vaccine, to be problematic based on the reasons that we have described on this channel today. And we don't feel that it should be promoted to our people, and particularly not being mandated to our people in order to get their public assistance. Now, every vaccine will not be a messenger RNA vaccine. There's other vaccines that will be based on the typical ways of developing vaccines through attenuation of viruses, meaning giving a weaker strand of the virus or killing off the virus or giving the protein coats of viruses. We feel that that would be, those are viable ways of creating a vaccine, but those haven't been developed yet and will not be completely developed until 2021 and 2022. We feel today at the Dirty Beaker that the main point of this is to question this. Go on those websites, question your senators, question your public officials, question the CDC about the safety of the messenger RNA viruses and whether they are safe and efficacious enough to give to the general population. We also urge everybody to continue to wear your mask, continue to social distance, and as we know, social distancing in an environment that is closed is not adequate when we talk virus can be aerosolized and be able to travel within 25 feet in 8 seconds. It can do that relatively fast, and it can live on surfaces for X amounts of days, particularly like cardboard surfaces or glass or stainless steel. It can last for maybe 2 days. So it's very important for us to continue to wipe things down, clean things, wash our hands, do not congregate amongst numerous people in order to circumvent some of our risk of COVID until we do find a vaccine that is safe and efficacious, or we find some natural remedies that the COVID virus. So I hope that this is clear. It's coming straight from the heart from the Dirty Beaker. We do this after our long science days. It's been a long science day today. It's going to be a long science day tomorrow. But this is the type of science that we enjoy, because this is the science for the people. We want to be there on the street for the people. And we hope that this is the street for everybody, and that we've provided some information that will help and guide you along the way to stay safe and look at this virus from the long run and not contract it. So again, thank you for joining us on the Dirty Beaker series. We appreciate all of our viewers.